Hey, what's going on, guys? Kinsey here. In this video we're going to write a function to fit a single tetromino into the Tetris board so that it gets rendered dynamically here, and we then would be able to move the tetromino like left, right, rotate it, and detect collisions and all this stuff. And again, like for those who could potentially miss the previous parts, I need to emphasize one more time that the settled down, so-called settled down tetrominos, those that are the part of the board itself, are different from those that we can still move, manipulate, rotate, whatever. So in this video, we're not going to be dealing with the static ones, but instead with the dynamic ones. So in order to get started with this, there is two essential things. So first, here we have 4x4. It's a string, but we can consider it as the array basically. So let's say we have this 4x4 array, and in order to get the content of this array, we can use exactly the same indexing system as we did here for getting the elements from the Tetris board, right? But also, there are two additional parameters that we need to rely on in regards to a single tetromino or Tetris space. Those are the coordinates. So let's go to the definition part. It's not the game constants. These are variables. And yeah, by the way, these are the GUI constants. So here, let's say game variables, right? So this is going to be the variable, and I call it position x. It's going to be equal to 4, so that it goes somewhere in between the board. It's just like the index to index the column of our board. And also variable position y, and it's going to be equal to -1, not 0, because otherwise it would appear like on the second line. So I want to appear this on the first line, and bear in mind the current implementation, it's better and easier to just give it a value of -1. But these are the essential values, and by the time of this video we're going to be manipulating the values just to give an idea how can we position a single given tetromino into literally whatever part of the board. All right, and finally, so here, draw Tetris, and let's go next. And here we want to draw a tetromino dynamically draw a tetromino. Hope I spelled this properly. I'm sorry if not. All right, so function, and I call it draw tetromino. It doesn't take any arguments. Other functions dealing with collision detection would have, but this one doesn't really need that. So here we need to loop over tetrominos rows. So just like we did here, here we did loop over the board, rows and columns. Here we loop over the tetrominos rows and colors. We can probably, tetromino size is already here, so we can use this variable nicely, right? So here, loop over tetrominos rows. I can say for let row equals to 0, row is less than tetromino size, row plus, and then the same for columns. So copy, and here loop over tetrominos columns, and here we have the column, and the column. And now we need to get to essential indexes to map one onto another. So again, we have like 1, 2, 3, 4. These are the indices I'm now mentioning. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? From 0 to 15. And these are the internal tetrominos indices. And also we have global indices, so we need to map these indices to fit our GUI element, because this dynamically, the reason why I say it's going to be dynamically placed, it means that it's not going to be the part of the Tetris board by the time it's falling down, moving left or right, rotates, and whatever for collision detection. So it's going to be completely relying on the GUI element. On this one we have here, and by the way, I can already go to part 3, so hopefully no errors yet. Okay, so now we need to define two essential indices. So the first one, want to define tetrominos index, and well, later on we're going to be using we will create a function to rotate the tetromino, but for now we'll use just the standard fixed definition as is. So let's just call it tetromino index is going to be equal to row multiplied by the tetromino, by the tetromino size by 4, or tetromino width. So this size, height and width are the same, so we can do it like this, plus the column. And the second one is what I call define the fit index. And this fit index is sort of a scaling from tetromino size to the whole board size. So let's say that fit index is equal to, and now we take our position x multiplied by the width of the board, of the Tetris board, plus position y here, position y plus position x, plus the current column that we have here, and all this is plus row multiplied by the width. So it's just a formula. You can check this out. I'm not going to be diving into the math because I'm stuck in math completely, but this is the formula I came up with using the trial and error method, which works like a charm. All right, and finally the most essential thing, we actually want to fit or render tetromino to screen. So here we need to take only those elements that are non-blank characters. So we need to reference tetrominos indexed by the type. So yeah, I just realized that we need one more variable here. Sorry guys. So we also need to have the variable current tetromino, and later on it would be taken randomly, but for now let's make it 0, and 0 is this one, right? So current tetromino, and also we'll have the current shape, but yeah, we'll better define it later to avoid defining variables that we're not going to be using directly just right at the moment. So I can say if, and now tetrominos indexed by current tetromino, and now indexing the string. So this string is indexed by the tetromino index. So if it's not equal to empty space, so it might be this @ symbol, or later on you may define more symbols that would be represented in different colors. So that's all fine. And here we want to say document dot get element by ID, and now the ID is this fit index. So we're using this fit index as the ID to get the certain GUI cell, one of this, depending on our position, and then say dot style dot background color. So we see like we do dynamically specify the background color of a given cell in the GUI, and here we use the tetromino color. Okay, so essentially this should already be enough. And let's say draw tetromino, and currently we have the coordinates, so let's give it a 0, so it should be somewhere here. Okay, I hold my breath and okay, probably get an error. All right, so width is not defined. Yes, it's not. It's called TETRIS width. Where is my width? So here, TETRIS width, obviously, and here as well. All right. Can I read style of null? Draw tetromino. So 163. All right, I know why this happens. This happens because we actually didn't yet create. Yes, we didn't yet create the. We didn't yet create the board itself, the GUI element. So we can do this. Well, we can actually say draw TETRIS here. And this should be, yeah, this does work, so it does render the piece actually, which is good. So this piece is different from this guy, so maybe just to give you an idea about this, so let's say make it green, for instance. So just to give you an idea that this piece is something that we can manipulate, place it where we want, etc. Yes, but just for the future, it's better to call this draw TETRIS directly from within draw tetromino, because otherwise it would be laggy. You know, like if we press the buttons to move them like left and right, it would be not updating properly. So to make it updating properly, we want to draw TETRIS here. But another option for this, in order to actually reference this, element, we need first to create GUI frame, let's say, so that later on we can actually reference the elements of this frame. So I think we can like leave it like this. And now just a few things for the future, basically. So for instance, I say 1 and it goes down, I say 2 and it goes down, I say 3 and it goes down. So I hope, guys, you already understand like how this is gonna be working. So I can also move it left and right. All right, I can move it left and right like this. And I can also use somewhat a different tetromino. So I can use tetromino 1, for instance, this one. I can use tetromino 2, tetromino 3, and so on, tetromino 4. So I hope that's clear. So let's drop it back to 4, like this. Yeah, so probably, well, I believe that the next video will handle the rotation of tetrominos, which is essential, and then we'll go for moving them and for collision detection, because collision detection also involves the rotation, so it shouldn't be hitting the walls during rotating. So I think that should go really first, and that's what I did first when I was preparing this series. Okay, guys, so this is it from my side. We've successfully rendered the tetromino dynamically to the GUI, to the current frame. And from now on, we can actually get closer to the game logic. This is it from my side. Thanks for watching. Until the next time, and take care.